You know, deep beneath our cities and towns, there's this vast hidden network. And right at the heart of it, there's this big rivalry, a real clash of engineering philosophies between two key materials. So today, we're diving straight into the great pipe debate. But first, why should you even care about this? Well, get this. Every single year, thousands of pipeline projects just fail. And it's not always about a bad installation or anything like that. The stakes here are incredibly high.
In fact, the success or failure of these massive, expensive infrastructure projects often boils down to a single critical decision, one that's made long before the first shovel ever hits the ground, and that's the choice of the right material.
And that brings us to our two main contenders stepping into the ring. On one side, we have the rigid powerhouse, GRP, that's glass reinforced plastic. And on the other, we've got the flexible contender, HDPE, high-density polyethylene. Two plastics, two completely different ways of tackling the same problem. So here's how we're going to break down this showdown. First up, a tale of two pipes, where we'll really get to know them. Then we get into the main event, strength versus flexibility. After that, we'll cover installation and lifespan, then the price of performance, and finally the big one, picking the right pipe. All right, let's get into it. Round one, a tale of two pipes. Before we can really see how they stack up, we've got to understand the core identity of each of these materials. So first up is GRP. The easiest way to think about this stuff, it's basically the carbon fiber of the pipe world. It's not just one thing. It's a composite material, a complex, layered structure. You've got these super strong glass fibers for strength, and they're all bonded together with a resin that gives it incredible resistance to corrosion. This stuff is purpose-built for demanding jobs. Okay, now let's meet its rival. HDPE is, well, it's a totally different beast. It's what we call a uniform thermoplastic. It's made from one main ingredient, this strong but really flexible plastic, usually PE100, with a few additives mixed in, like carbon black to protect it from the sun. Its whole identity is built around simplicity and being able to adapt. And this fundamental difference, it starts right from the moment they're made. GRP manufacturing is a really complex, multi-step process. Think of filament winding, where you're carefully wrapping fibers and soaking them in resin. HDP, on the other hand, it's made through a much simpler single-step process called extrusion. So right from the get-go, their complexity, their cost, and even their quality control are worlds apart. And now for the main event, strength versus flexibility. This is really where the core differences between these two materials go head-to-head and define how they're going to perform out there in the real world. Let's get a little nerdy for a second and just look at the raw data. So you've got tensile strength. That's how much you can pull on it before it snaps. Elastic modulus. That's just a fancy way of saying how stiff it is. And elongation. How much it can stretch before it breaks. And as you can see, the numbers aren't just a little different. They are massively different. And wow, this chart really tells the story, doesn't it? Just look at tensile strength. GRP is clocking in somewhere around 350 megapascals. HDP, maybe 25. The GRP bar just completely dwarfs the HDP one. This one image makes the whole idea of GRP's incredible rigidity crystal clear.
So, what do those numbers actually mean out on a job site? Well, GRP is the unbending giant. It has really low ductility, which means it resists changing shape, even under a heavy load. But HDPE, that's the agile adapter. It's so ductile, it can stretch up to 600% of its length and just flexes with the ground. I mean, that's a superpower in a situation like an earthquake, where the ability to bend instead of break is everything. Okay, so we've talked theory and properties, but how does this all play out in the real world? Let's move on to our next section. Installation and lifespan. How do they actually perform out in the field, not just for a day, but for decades?
Now, when you're actually on the job site trying to get these pipes in the ground, there's a really clear trade-off. GRP installation, it's generally slower. It needs specialized tools, skilled labor for its balanced bigot joints. HDPE, on the other hand, is usually faster. You can use standard equipment to create these butt fusion joints, which gives it a huge leg up in terms of speed and just ease of use. But what about the long haul? I mean, how long do these things actually last? Well, the good news is both of these are seriously durable materials. If you pick the right one for the job and install it correctly, both GRP and HDPE pipes can easily hit a 50-year lifespan, and they could even last for 100 years with minimal upkeep. It really just comes down to putting them in the right environment to begin with.
Of course, no project ever gets off the ground without talking about money. So let's dive into the price of performance, where we're going to look at that upfront cost versus the all-important long-term value.
And this is that classic debate, right? The sticker price versus the total cost of ownership over its entire lifetime. GRP often has a higher initial cost, mostly because of that complex manufacturing we talked about. But since its maintenance needs are so low, its total cost can be really competitive. HDPE usually wins on the initial price tag, and since it also needs very little maintenance, its total cost is also really, really good. The key thing to remember is that you can't just look at that upfront price.
And that brings us to our final and honestly our most important section, picking the right pipe. Now, this isn't about declaring one overall winner. It's about choosing the right champion for a very specific arena.
So let me throw a scenario at you. Imagine you're the project lead. Your challenge is to build a pipeline in an active earthquake zone. Or maybe you have to use a trenchless installation method because you can't just dig up a busy city street. Who do you call?
For this one, the champion is absolutely clear. It's HDPE. Its incredible flexibility becomes a superpower here. It can literally move and bend with the ground during a tremor, and it's perfect for being pulled through the ground when you can't dig big trenches. No contest.
Okay, let's flip the script. How about a totally different challenge? This time you're building a massive, high-pressure water main. Or maybe an industrial system that has to move some seriously corrosive chemicals day in and day out. In this arena, the crown goes to GRP. Its immense strength and its layered, corrosion-resistant body make it the undisputed winner for handling that kind of intense internal pressure and fighting off harsh chemicals. Here, its rigidity is its greatest strength. So, the takeaway here is that context is king. The best pipe is simply the one that's best for your specific project. This 5-step guide is really your practical roadmap. Define your needs, pressure, environment, check the terrain, and how you're going to install it. Crunch the numbers, both upfront and long-term. Make sure you're meeting regulations, and probably most important of all, talk to your team. And all this leaves us with one final thought to chew on. As we keep building and maintaining these hidden networks that our entire world relies on, it's worth asking, what really matters more? The unbending strength to resist all the forces acting on you, or the power to adapt and move with them? The answer, as we've seen today, is it depends.